Hi guys, welcome to the last class for SS1 first term, and that is the last lecture. That's lecture 7, and that is speed, velocity, and what acceleration. So what are we going to be discussing in this topic? Okay, so our content, so the course outline, we're going to be discussing on what speed is. We're going to be discussing on the terminologies used in speed. We talk about velocity, talk about uniform velocity, talk about acceleration. So those are the things we are going to be talking about. Uniform acceleration. So what do these things mean and how to solve questions from them. So talk about what is deceleration. So these are what we are going to be discussing. So let's go to the first outline. So we talk about speed. What is the meaning of speed? We have talked about displacement, we've talked about distance, we've talked about position. So what is speed? So speed is what? The rate at which a body covers a distance. How fast does a body covers a distance? It is denoted by what? V, that is the symbol for speed. It is measured in meter per second, and it is what? A scalar quantity, meaning that it has magnitude but no direction. Now mathematically, it is expressed as what? Speed is equals to what? Distance moved or distance covered over what? Time. Now we should also note that speed also have other units, because we can measure distance also in centimeters. So we can have centimeter per second. We can also have kilometer per hour. Now let's go to terminologies used. So the first terminology is what? Uniform speed. When do we say we have a uniform speed? Uniform speed, so a body is said to be traveling with what? Uniform speed when that body covers equal distance in equal time interval. So we can also say this is what? Constant speed. So for example, a body is covering 3 kilometers every 1 second. So that body is said to be what? Uniform speed. Is moving with uniform speed because the speed was not changing, and it means that the distance it was covering and the time is still what? The same. So let's talk about what? Average speed. What is average speed? Average speed is the total distance traveled divided by the total time taken. So the total distance a body traveled divided by the total time it took for that body to cover that distance. So average speed is a better representation of the motion of a body, not moving at what? A constant or uniform speed. So it is mathematically represented by average speed is equals to what? Total distance covered over what? Total time taken. So there's difference between uniform speed and what? Average speed. Now let's talk about instantaneous. Now look at the word instantaneous. It's gotten from the word instant. So it means speed of a body at what? An instant. So that is meaning of what? Instantaneous speed. The actual speed of a body at any instant during the course of what? Motion. Okay, let's go to velocity. What is velocity? Velocity is the rate of change of displacement. Now for speed, it was rate of change of distance. So from our last class, we talked about speed, distance, and what? Displacement. So velocity is the rate of change of displacement. It is also denoted by what? V, and it's a vector quantity because displacement is what? Vector, and it is expressed as what? Velocity equals to what? Displacement over what? Time. So that is V is equals to S over T, and velocity is measured in what? Meter over second, because displacement is measured in meters, so that is meter over second. And also we have possibility of having other units like kilometer per hour, centimeter per second. So let's talk about uniform speed, uniform velocity. Sorry. Now what is uniform velocity? So a body is said to be traveling with uniform velocity or constant velocity when the body covers a constant displacement in equal time interval. So the same thing. But now note something. A body can be traveling in, let's say a body is traveling at constant speed in a circular path. The velocity will not be constant. Why? Because when a body is going around a circular path, like an example, roundabout, even though the speed is constant, the direction is always changing. Check the tangential direction. Is always changing. So because of that, a body moving round a roundabout or around a circular path may have a constant speed but not a constant velocity, because the direction is always what? Changing. Okay, let's talk about differences between speed and velocity. The first differences is their definition. Now speed, okay, go back. Okay, let's talk about it. Speed now is what? The rate of change of what? Distance. Rate of change of distance with time. While velocity is what? The rate of change of displacement. Now, speed is what? A scalar quantity, meaning that it has magnitude but no direction. While velocity is a vector quantity, it has magnitude and direction. Speed is calculated as distance over time, while velocity is calculated as what? Displacement over time. So these are the what? Differences between what? Speed and velocity. Now let's go to the next one and a work example. Now look at this example. They say a car covers a distance of what? 60 km in half an hour. What is the average speed of the car in kilometer per hour? B. Meter per second. Solution. So the first thing we know is that they told us the time is half an hour. So half an hour actually means what? 0.5 hours. That is half of an hour, because we are trying to get kilometer per hour. Now, they told us that they have already given us distance as 60 km. So what is average speed? Total distance covered divided by the total time taken. So that's going to give us 60 km over what? 0.5. So the answer is going to be what? 120 km per hour. Now to convert this to what? Meter per second, what do we do? We know that what? 1 km per hour is actually going to be what? 1000. That is, remember, 1 kilometer is what? 1000 meter, and 1 hour is what? 60 times 60 seconds. So that is why you see that is 1 kilometer per hour is going to be 1000 meters over 60 times 60 seconds. So what we just need to do, if 1 kilometer is 1000 days, okay, that is what we just said. Now, so what we just need to do, convert 120 km per hour to what? Meter per second. Is just by saying 120 multiplied by 1000 divided by 60 times 60, and that gives us 33.33 meter per second. So what it means is that 120 km per hour is still the same thing as what? 33.33 meter per second. Okay, next example. A car covers 1500 meters in 10 seconds. What is the speed in kilometer per hour? So we are trying to test our knowledge on conversion. So what we are going to do is that we will first of all convert it to meter per second. So speed is what? Distance over time. So it means that our distance there is what? 1500 divided by 10 seconds. So that gave us what? 150 meter per second. So we now have to convert this to what? Kilometer. How do we convert this to kilometer? Remember, 1 kilometer per hour is the same thing as what? 1000 over 60 times 60 meter per second. So if we now want to make 1 meter per second the subject of formula, so it means that the other part will be what? Reversed. So it's now going to be what? 60 times 60 over 1000. That is just by making cross multiplication. So the 1 kilometer is going to times the denominator, that is 60 times 60, then divide both sides by what? 1000. So once we do that, so we just say 150 meter per second is going to be what? 150 times 60 times 60 over 1000, and this gives us what? 540 kilometer per watt hour. Okay, let's go to example 3. A car traveled to Abuja a distance of what? 1000 meter in 50 seconds. This guy tried to calculate the what? Average speed. So average speed, they did not tell us the unit. Now since they didn't tell us the unit, we have to work with what? The SI unit. So we leave it that way. So 1000 is the distance and the time is what? 50 seconds. So what is our average speed? Average speed is what? Total distance covered over total time taken, and that is going to give us 1000 divided by 50. So our answer is going to be what? 20 meter per second. No need to convert since we were not asked to convert it to any other unit, so we leave it on the what? SI unit. Okay, next example, example 4. A car moves with a speed of 54 km per hour for 1/4 minute. Find the distance traveled by the train. Now we have the speed here. We have the speed here as what? 54 km per hour, and we have the time. The time is what? 1/4 minute. So what we need to do is we convert the speed to what? Meter per second. Remember, convert speed to meter per second. Let it be at the SI unit. Now, to do that, we have already discussed how to do that. So multiply that by 1000 divided by what? 3600, and that gives us what? 15 meter per second. Then the next thing for the time is what? 1/4 minutes. We convert it to second. 60 seconds make 1 minute, so it's going to be what? 1/4 times 60. So that is going to give us what? 15 seconds. So what is the formula for what? Distance. Remember, speed was actually what? Distance over time. So if you make distance the surrogate of formula, it will become what? Distance is equals to speed times time. Now, imputing these values, so it means that the distance is going to be 15 back. So the distance is going to be what? 15 times what? 15, which is what? 225 meters. Okay, let's go to acceleration. What is acceleration? Acceleration is the rate of change of what? Velocity with time. It is denoted by the symbol A. It is a vector quantity. Why? Because velocity is also a vector quantity. It is expressed mathematically as what? Acceleration is equal to what? Change in velocity over time. Now, what is change in velocity? Now, we have v standing as the final velocity and u standing as the initial velocity divided by what? Time. So final velocity is measured in meter per second. U, initial velocity, is also meter per second. T is what? Time, which is second. So what is the unit of acceleration? Meter per second divided by second, and that is going to give us what? Meter per what? Second square. Now note, when a body starts from rest, its initial velocity is 0, and when the body comes to rest, its final velocity is also what? 0. Okay, now let's talk about uniform acceleration. When do we say that an acceleration is what? Uniform. A body is said to be traveling with uniform acceleration or constant acceleration when the body covers an equal velocity with an equal time interval. So that is to say, the way it was changing its velocity is constant for a time interval. So the rate of change of velocity with time is not constant. If it is not constant, it means that the acceleration is non-uniform. Now let's talk about deceleration or retardation. What is the meaning of deceleration? What is the meaning of retardation? Both of them are the same. So deceleration is what? The rate of negative change in velocity with time. So acceleration is positive, deceleration is negative. Now when this thing happens, the velocity of the body is what? Reducing or coming to rest. So deceleration happens when the velocity of a body is coming down, decreasing. Acceleration happens when a body, the velocity of a body is going up. Now for those of you that are conversant with car, now for acceleration, if you want to accelerate the car, that is to say you want to increase the speed of the car, you step on the what? Accelerator. The accelerator changes the velocity. Now if you want to reduce the speed, you step on the what? Brake. So brake brings about deceleration, accelerator brings about what? Acceleration. So deceleration is said to be uniform, just as we have talked about, when the body, if the velocity decreases by equal amount in equal time interval. Now note, for deceleration it is what? Negative. Now deceleration is mathematically represented as change in velocity over time, and that is going to be v minus u, that is final, minus u all over what? T. Since it is reducing, so it means that the final should be smaller than the what? Initial, and that is what is going to make our deceleration to be what? Negative. And also you should note that it is also measured with the same unit of acceleration, that is what? Meter per second square, and it is what? A vector quantity. Now let's go to what? Some examples on that is, a body experiences a change in velocity of 10 meter per second in 5 seconds. What is the acceleration of the body? Solution. Now they have given us a change in the velocity as 10 meter per second, and they say the acceleration is what? The time is what? Is 5 seconds. What is acceleration? Acceleration is what? Change in what? Velocity over time. So, and that is going to give us 10 divided by 5, and that will give us what? 2 meter per second. That is the acceleration. Now example 6. A car accelerated uniformly at what? 5 meter per second. This is the acceleration in 20 seconds. That is the time. We are being asked to find the change in velocity. Now, very simple. These are the given. Now remember that acceleration is what? Change in velocity over time. So we make change in velocity solid of formula. So it means that change in velocity will be what? Acceleration over time times time. So it means that change in velocity will be what? 5, which is the acceleration times 20. And that is going to give us what? 100 meter per second. So that is our answer. So next example, example 7. The velocity of a bus decreases from 60 km per hour to what? 35 km per hour in 0.5 minutes. Find the deceleration. This question is tricky. Remember, they didn't tell us the unit to find the deceleration. So we have to convert these velocities into what? Meter per second, so that it will be in the SI unit. So converting that, so it started from 60. So 60 becomes our what? Initial velocity. So we convert 60 km per hour to what? Meter per second, applying that formula, and that is going to give us 16.67 meter per second. Then our final velocity is what? 35. We convert 35 km per hour to what? Meter per second, and that gives us 9.72 meter per second. Then the next thing is the time. The time was 0.5 minutes. Convert time to the SI unit, which is what? Seconds, and that is going to be what? Remember, 60 seconds make 1 minute, so that is 0.5 times 60, and that is going to give us what? 30 seconds. So we are being asked to find deceleration. So remember, deceleration is what? Change in velocity over time. So change in velocity is v minus u over t. So that is going to be what? 9.72 minus 16.67 divided by 30, and that is what? Minus 6.95 over 30. So therefore our deceleration is what? Minus 0.23 meter per second. You see that we got a negative answer because it was actually what reducing. Okay, so these are the exercises that you can try to solve along to check if you actually understand our classes. So remember, thank you very much for listening to this class. So thank you also for coming to the end of what? SS1 first term. Thank you for your patience. So see you in SS2 series. So remember to subscribe, like, share.